Hi everyone. Once again I welcome all the students in our this session, and we have already started a chapter from chemistry, that is matter and its composition. So in our previous lecture just we have started this chapter and we have discussed about what is matter. So we have just seen everything which we are looking our around, they are made by the matter only, right? And then we have seen the things we have divided into the artificial or natural, man-made or natural. But each and every things we have concluded that is made by the matter, whether it is solid, liquid or gas. There are the three type of the matter, and then we have seen what is the characteristics of the matter. What is definition, means anything that occupy the space and have the mass, that is called the matter. So on the basis of that definition, we have divided this all solid, liquid and gas, and then with the help of several activities we have already seen that matter will occupy the mass and have the it will occupy the space and have the mass. And through this activity, like several activities we have seen to define how the this is actually going to explain about the liquid. Once the liquid is enough into the glass, so if you pour the new liquid, it will not be stand into the liquid before it is having already inside. So that is show that the liquid will occupy the space. And in we have seen in this other activity, that is it will have the mass, the water filled in the glass, that part will be, or that glass will be so the means weighing balance will be tilted in one side. So and in this next activity you have seen the gas also, it will occupy the space and have the mass. So this is how we are means going through this chapter. And then we have seen that this matter, actually they made by molecules, and molecules are made by the atoms. So atom is going to be a smallest quantity of the matter, or smallest quantity of any matter, which is going to be solid, liquid or gas. And we have already said the matter or any molecules or any matter means any atoms, they are having all the qualities or all the characteristics of the matter which it is made. Like we are talking about the molecules of water. So one drop of the one molecule also having all the characteristics of the liquid or the water, which is the molecule of that water. If we take the example of solid also and gas also, so all the atoms or all the molecules, they are having the, or they are existing the same characteristics of the matter which is made, right? So that is the smallest quantity or smallest things we have seen, that is atom. And then it will number of atom, an atom cannot be means stay alone, that is why it is combining with some other atom, more than one atom, it will make the molecule. And we have seen this means the same atom can also be combined together and make the molecules. Sometimes the other two kind of the molecules, so sorry, two kind of the atoms, they can be combined together and can be make any molecules. So example we have seen the example of hydrogen molecule, the example of water molecules. So in the example of water molecule, there are two different kind of the atoms, one is carbon, one is oxygen, and two is H hydrogen. So 2H and 1O, they are combined together and they will make the molecule of water. One more example we have seen, that is carbon dioxide, one molecule of one atom of carbon and two atom of oxygen will make the CO2. So and then we have seen in the next slide, that is how the what are the characteristics of any matter, that can be means they are having the intermolecular spaces, they are having the intermolecular force, and the molecules are moving continuously, moving in like depending on solid, it will move in a same place, the molecules. Liquid molecule can be moved into the boundaries or in the bulk, and gaseous molecule can be moved into anywhere wherever it is found the space, right? So this through this activity we have seen how the molecules are moving into the solid, liquid and gas. So or in the next slide, then we have started that means molecules are having intermolecular forces, that is the thing which is combining all the molecules and they are being together. So we have seen the example of this wooden block, and if you want to break the wooden block, it needs more energy, we cannot do by our hand. Why? Because the molecules which are present into the wooden block, they are tightly packed together, because the intermolecular force are more into them, that is why they are tightly packed and we cannot move it or we cannot break it easily. when we have seen example of chalk piece also, so we can easily break it because there is some less intermolecular force as compared to the wooden. And we have seen the liquid also, when we are just throwing the water with one spoon. So when the water droplets are coming down, they are taking the spherical shape because the molecules of the water, they are joined together. So all the matters whatever we are looking here, they having the intermolecular forces, and that is why they are combined together and they are having a one one piece, you can also say. So all this shows that the intermolecular forces of attraction between the particles of the wooden box, chalk piece and water. So hence it is proved that intermolecular attraction between the particles keeps them together. This is the intermolecular attraction is the one which are means they are holding all the molecules of solid, liquid and gas, and they are being together. So these are the some characteristics we have seen: the intermolecular space, intermolecular force, and what will be happen into the matter because of these qualities. So the next we will start with the state of the matter. So the next thing we will start that what is actually the state of the matter is there, what are the states they are having, we will just discuss in this next paragraph. So as we have seen the example of the water, water is means substance which can be have into the all the three state. It can be exist into the solid, can be liquid or can be gas. So this is very good example, we can be just discuss about it. So it can be changing, and how it is changing from one state to another state, that is a very important thing. So now we just know that the intermolecular spaces, intermolecular attraction and the random motion, these are the three basic characteristics of any substance, that is they are having the intermolecular forces. That is why depending on the force they are having the different intermolecular space, and then they are having the movement or motion in that molecules, that is important characteristics, or the particles of any kind of the matter. In the matter particle it can be having this kind of the characteristics. So if the force of attraction increases, the molecule move closer and the space between them decreases. So this is what actually happening, how the water which is converting from liquid to ice, that is a solid, from ice to liquid or from liquid to gas, because when we are in decreasing the temperature, we are putting the water into the ice or into the refrigerator or freezer, so there is a temperature is very low. So because of that the molecules of the water, they are coming together, their force of attraction is increasing and they are coming closer, and the space between the molecules will decrease, because if the more force of attraction between the molecule, so there is a less space between the intermolecular space is less. So that is the reason. And if the force of attraction, and then if we means decrease the energy, intermolecular forces, so when we are decreasing intermolecular forces, the space between the molecule will be increased. So when we are in the example of when we are putting the ice into the room on the room temperature, so it will melting. So what happened that time, the intermolecular forces between the molecules of that water or that ice will be reduced. So when the molecular forces will reduce, the molecule will be released and then will be having a more gap. So there being more gap into all the molecules, so it will converting into the water. So that is why. And if the force of the attraction decreases, molecules moves apart and the space between them increases. So when the space between the molecule will increase, it will convert into the liquid state, right. So this is the reason the water can be have the solid and liquid both the things. And then so this is fact account. And when more point is there, that when we are boiling to the water, so there is again and again releasing the energy from it, and the intermolecular forces will very least, and the molecules intermolecular forces intermolecular space is very high, so it is free to move in anywhere. So that is why the steam will produce and the water will convert into the steam and vapors. So whenever the it's found the way, it can be move into that place. So that is why it is having the it can be move in all the space whatever we are providing it. So this is fact the account of the three different state of the matter, that is a solid, liquid and gas. So in more detail we will just see one by one what happened into the solid, what happened into the liquid, or in the case of gas. So, we will start with the solid. So, in the solid, a solid has a definite shape and definite volume. This we have seen in the beginning of this chapter. The matter of the solid, they having definite shape as well as definite volume. Why it is having this both the kind of the characters? Because the particles are tightly packed together, right? So, if the particles are tightly packed together, the intermolecular forces are more, so intermolecular space are less, so they are strongly they are attracted together, and that is why it is feel that is it is hard and not free to move. So, molecules will just only, the particle will move only on a mean position, they cannot move in a other place, they can only vibrate about the mean position. And solid are rigid and incompressible, we cannot compress it because the molecules are already so much closer. So, there is no chance for again compression, that is very incompressible, very hard to compress. Then we will talk about the liquid. In the liquid, that it is having the definite volume but does not having the definite shape. What is the reason it does not have the definite shape? Because the particles of the liquid are less tightly packed together. And why it is less tightly packed? Because the force of attraction is lesser or weaker as compared to the solid. So, if the force of attraction is lesser or weaker, the intermolecular space will be larger, and thus the particles are free to move within the bulk, within the boundaries. Liquid can be flow, and therefore it is called the fluid. So, the reason is intermolecular forces are less in the liquid as compared to the solid. So, that is why the molecules are free to move in the boundaries or in the bulk of that whatever the amount of the water is there. So, that is why we can say that is it is called the fluid, and fluid means what? It can be moved, or it can be moved into the boundaries, right? Fluid in the sense fluid also come the liquid and gas, both the come into the fluid. An example you can say the water, oil, alcohol, petrol, these all are the example for the fluid. And then we can consider an experiment. Take up a glass. So, what is actually in this experiment we can see here, we have seen that experiment, whatever the liquid is a fluid, it can be moved into the bulk. So, whatever container it is having, it is take the shape of the container that we have seen before. So, if you take the cup, if you take the glass, if you take the other bottles, so whenever we are putting the water, it will just changing the, it is taking the shape of that whatever the means flask or glass we are taking. So, that is the reason, because it does not having the means particular shape. And then we will talk about the gas. So, gas neither a definite shape and nor a definite volume. Why? Because the intermolecular forces into the gas, they are very least. So, if the intermolecular forces are very weak, so the intermolecular spaces are very higher, and then it is very free to move in any direction and any container which we are putting. We have already seen the example of this activity. In one container there is a colored gas, and in one container there is empty. So, when we are just combine both the container, it is just moving into the all the space. So, that is why it becoming all the container will becoming the colorful. And then we have started properties. We have seen intermolecular spaces are how in the solid, liquid and gas. Intermolecular shapes also we have seen, or the property of the shape we have seen in solid, liquid, gas. Means the shape of the solid is fixed, but the shape of the liquid and gas is not fixed, because their molecules are free to move, right? So, that is why we have discussed about so many characteristics. And in the next table there is some more characteristics are there, like fluidity. Fluid means as I told you, the matter or the matter can be moved or can be means flow. So, that is called the fluidity. So, definitely the liquid is fluid, or gas is also fluid, but solid will not fluid. So, it is, that is what is said, do not fluid, right. So, this is the characteristics called fluidity. Then we will see the effect of the pressure, that is compression. So, already the solid molecules are very tightly packed. So, effect of compression is very low. When we are pressurizing or compressing a solid, it will not compress, because already the molecules are very closer to each other because of the more intermolecular forces. So, it cannot be compressed. When we are talking about the liquid, it is a effect of pressure is higher than a solid. As you compare to the solid, it is more compressible. When we are talking about the gas, the effect of pressure is very high. When you compare the gas, it will compressible, highly compressible as compared to the liquid and solid. Then we will see the transparency, how it can be transferable or not. So transparency, solid are generally opaque, and that is why example like wood or stones etc. So glass and diamond are transparent, only the glass and diamond that are the solid which can be transferable, but normally the solids are opaque in the shape, so it cannot be transferable. When we will talk about the liquids, so mostly pure liquids are transferable in the nature or transparent in the nature, example water, alcohol, petrol. So these are the liquid which are transferable, other liquids are not transferable. Then gases, all the gases, oxygen, nitrogen, carbon dioxide are transparent in nature. So the gases are mostly they are transferable in the nature. These are the characteristics. Next characteristics, luster, means how they shine or not. So amongst the solid, all the metals have luster. When we just divide the solid into metal and non-metal, so all the metals are normally shiny, they can be shine, or that is called the lustrous. And when we talk about the liquid, among the liquid, mercury is lustrous. In all the liquid you can say the mercury is it's having the lustrous quality, and the gases are not lustrous, it's not shiny. We have not seen any gas that will be shine, so that is a lustrous quality is not there. And the lastly, solubility in the water, which molecules or solid, liquid, gas can be soluble into the water or not. So a large number of the solids are insoluble in the water, example wood and mud etc., stones we can see. So some solids such as the sugar, common salt are soluble in the nature in the water, right. So normally the solids are not soluble, insoluble in the water, but we are just taking the example of salt and sugar, so it can be soluble into the water, right. Then we are having taking example of liquid. So liquid can be miscible as well as immiscible. Miscible means it can be completely, two liquids can completely mix together, we have seen in our previous classes, that is called miscible. And immiscible, the liquid cannot be mixed completely to the other liquid, that is we have take the example of water and oil. So oil is immiscible in the water. So example, alcohol and vinegar are soluble. When you are adding the alcohol and mineral together, alcohol and vinegar, so they can be miscible, they can be combined, or while we are taking the oil and water and petrol, so an oil is means this is the immiscible combination, so that is a different in different kind of the liquids, it's not same for all. And when we are talking about the gas, so some gases are insoluble or in water, example nitrogen, hydrogen, so that are the insoluble. And some gases are soluble, that are the oxygen, carbon dioxide, ammonia etc. So these gases are soluble. So here also some gases can be soluble, some can be non-soluble. So that is we have seen solubility in the water. So then we will start with interconversion of the state of matter. What is mean by interconversion? It can be converted from one state to another state, from solid to liquid, liquid to gas, and gas to vapor. So that is the interconversion of the state of the matter is process by which the matter changes from one state to another state, from solid to liquid, liquid to gas, gas to liquid. This is the interconversion, and that is without any change in its chemical composition. It is changing only the state, but the chemical composition will not change, it will becoming same in all the states. So that is why it is called the interconversion. The change in the state of the matter mainly caused by, and what are the reasons how the means the state will be changed. These are some points you have to keep in mind. Number one, change in the temperature, another is by the applying the pressure. While we are changing the temperature, it can be change the state of the matter, or while we are applying a pressure, it can also be change the state of the matter. So very first we will see change in the state by changing the temperature, right. This is the number one. So in everyday life we come across so many substances that can be changed from one state to another state. So we will see this condition. So number one condition, that is change in the state by changing the temperature. This is the number one we will discuss here. So when increases the temperature, when we are increasing the temperature, solid changes into the liquid and then into the vapor. As we are taking the example of water, when we are just increasing the temperature of the water, it can be changes into the, or if you are taking the example of ice, so when we are increasing the temperature of the ice, it will melt, it will convert into the liquid. When we are again changing the temperature, it can also be we are providing more heat, it can be vapor form, can be converted. So temperature, and when we are decreasing the temperature, it will happen just reverse. Reverse means what? We are just in condensation we are doing, we are just trapping the vapors, so it will reduce the temperature, convert into the liquid. When we are keeping into the refrigerator, again we are decreasing the temperature, so it will convert into the solid form. So this is the matter, or this is the thing which is temperature can be affecting the state or changing the states. So for example, we have seen the water. So water is a liquid under ordinary condition, but when it is kept into the refrigerator, it will convert into the solid like ice, or when cooled again change to the liquid, and then if you are increasing the temperature, again it will evaporate. So ice when kept at a room temperature again change back to the liquid water, or water when heated starts changing into the steam above 100 degrees centigrade, and when it is steam we have just cooled it, again it can be changes into the liquid. So this is the cycle of in the form of liquid, you can say. In the water it can be changed into the all the type or all the states from one state to another state, right. So now we will just have this diagram. Actually this is very important diagram. This is a molecular arrangement. If you understood this arrangement of the molecule, you will understand all the states. So number one, A, molecules lie closely and packed together with a greater force of attraction between them, right. In this slide it is showing, you can see all these are the smaller, these are the molecules. So these molecules, they are very closely packed together. So if they are very closely packed together, the force of attraction is more, so that is why it is becoming very harder and it is very tough. So that is why the solid having a mass also, and it is having the definite shape. And if the movement of the molecule in a mean position only, so that is why it cannot be moved. When we are talking about the liquid, so in the B you can see the molecules of the liquid, they are having a special some gaps are there. It's not totally packed like a solid. So molecules lie fairly less apart from each other and with the little force of attraction between them. So why it is happening, why there is a relaxable into the molecules, because the force of attraction is less or least as compared to the solid. That is why the gas can be the liquid can be move into the bulk or into the boundaries, and that is why it doesn't having a fixed shape. When we see the example of gases, so here you can see the molecules, they are very apart from each other, the distance is too high. So what is the reason? The intermolecular forces are very least as compared to the liquid or gas. So that is why they are very far away from each other, and because of the very little force of attraction is there. So that is why the gas can be moved in the boundary or in the whatever the container or in we are putting into the gas, it can be take the all the space of that, and it is very free to move in the environment. So in all the three states, the property of the water remains same, but the thing we have to keep in mind, the property of the water is not changing, it is becoming in a same property, it is having the same property of the water in all the states. It becoming any means like ice or water or steam. So the basic property of the liquid will be not change in any state. So that is thing we have to be keep in mind. So when the substances change from solid to liquid, liquid to gas or vapor, so what will happen if you are just melting something, means like we are melting the ice, so that time if the substance will convert from solid to liquid or liquid to gas, so the energy will be released from that matter, energy will be lost. And when it's opposite, when the heat will be lost. And when we are just doing opposite, means from we are changing the liquid to solid or from vapor to liquid, so that time the energy will be or the heat will be absorbed in a same amount. So that is why the exchange of the energy or conversion almost zero, the energy or the net amount of the energy will become zero. And that is why because the changing in the states does not change the chemical composition of the substance. Chemical composition, why it is becoming same? Because the heat is lost or heat is absorbing when the molecules are just changing from solid or liquid, solid to liquid or liquid to gas, the energy will be lost. And when we are doing opposite, from liquid to solid we are doing, so the energy will be or the heat will be absorbed. So in the both the form the energy will be balanced, and that is why the chemical composition is not changed. And when it's having the we want to change the chemical composition, so there is need of the breakdown of the molecules of the sequence will be changed. So that is why the properties will becoming same. And another example, we can take the wax. When we are just ignite the candle, the solid wax melt into the liquid wax, right. So some rises or which rises the wick, near the wick, and wax near the glowing wick melt, and some part of the molten wax trickle down and solidified. Some wax will be melt, and that is when it is coming to the down, it will again solidify. So and when we can also see the example of ice, we have already seen. In this it is just showing when we are giving heat to the ice, it will melt. When we are again means we are heating to that liquid, it is becoming into the vapor form. Opposite we are doing, we just cooling it, so again it will come opposite cycle. So that is the reason the state of the matter will be changed, but the property will become same. So in the both the above cases, the changes of the state or the substances is due to the change in temperature, right. How we can convert the liquid to ice and ice to again liquid, and in the vapor we have to provide the heat. So that is the reason it is a temperature is a very important thing. The change of the states by the pressure, how we can be change the state, that is sometime applying the pressure, means the state of the substance can also be changed by the applying the pressure. For example, gases on increasing the pressure change into the liquid form, like. So thus we can obtain the liquid oxygen, liquid carbon dioxide, or liquid cooking gas, right. If you take the example of our cooking gas, so it is actually the gas, but while it is written over here liquid means liquefied petroleum gas, so it is in the form of liquid. When we are just moving the cylinder, you can feel that the liquid gas is there, but while we are just releasing the pressure with your knob or your regulator, so it will coming into the form of gas. So what will happen, they have just pressurized to that gas, and that gas is just changed into the liquid. So that is why we are having the liquid gas in the form like oxygen, or we are using into the hospitals. So it is also look the liquid form, and carbon dioxide also in the liquid form, and cooking gas. So that is the reason they have just pressurized the gas, and it is just changed into the liquid, and when we release the pressure, again it will just change into the gas. So this is the thing we have to keep in mind. And the cooking gas that is sold in the gas cylinder also in the form of liquid under the pressure, that it is mentioned liquefied petroleum. And when regulator, that we have already discussed, when we open the regulator, it is again pressure, because the pressure will be released, so this liquid gas again convert into the gaseous form, right. So it releases, and LPG comes out in the form of gas. So this is, there are the some substances like again camphor and naphthalene, iodine crystals, ammonium or chloride, etc. These are the changes directly from solid to gaseous form. It is not melting and then converting into the liquid and then gas. It is directly from the solid to vapor form or into the gaseous form, they will just convert, and we change so gaseous state. And on heating, but there is a need of heating, and vice versa, when you are just cooling, again from a gas to directly solid form, it will be just convert. So that is in this cycle you can be just understand the process that is called the sublimation. So sublimation is the process in which some substances like camphor, naphthalene and iodine, they iodine crystal, when you giving heat, so from solid it directly convert into the gaseous form, and when we are just releasing the heat temperature, it will be directly convert from a gas form to solid form, that is called sublimation. There is no any kind of the liquid state, directly it can be just skipping the liquid state. You can be see the example of liquid in this cycle. This is suppose your naphthalene ball, and that it is in a solid form, and when it you are giving the heat, or it is called the sublimation, so it will evaporate, or evaporation is there, and directly it is converted into the gas. And when we are condensation, so it is again converted into the liquid form, right. So that is a normal process we can be say, but in the sublimation from the solid it is directly converted into the gaseous form, right. What is a normal cycle is should be like this, from a solid, then we can be going to the liquid form, from liquid to again. So but in this case, sublimation from liquid to gas, or that is the evaporation, and here this is sublimation from solid to directly gas, or deposition from gas to directly solid. So, this is going to be a normal cycle, and this is from solid to gas, that is becoming a sublimation directly in the form of naphthalene or iodine crystals. We can be see while giving the heat, it is directly convert from solid to gas, and opposite, that is called deposition, directly from gaseous to solid form. So, in this cycle there is no any liquid form, there are directly conversion from solid to gas and gas to solid, right. And if you go to the another normal our means molecules, like they are convert from liquid to gas, then gas to liquid, then from again from liquid to solid. So, this is going to be a normal process, but when we are just talking about the sublimation, this is only like this in this direction and opposite into this direction. So, that is called the sublimation process, and this is actually happening into the some substances that we have seen in our examples. So, here we will we have finished our chapter. So, there are some exercise questions also there, and I request the students to just write down the important points, write down some answers of the questions, and also will provide several questions to you. So, we will see you in the next lecture. We will start the next chapter. Take care.